Hello, and on behalf of the Royal Academy of Engineering, of me and everyone else involved in this event, welcome to Powering Net Zero Britain. I'm Dr Helen Czerski. I'm a physicist in the Department of Mechanical Engineering at University College London, and the engineers in my department and lots of others spend a lot of time thinking about the engineering challenges that might be involved in getting to a place where our society runs in a net zero way by 2050. That is our stated challenge, our stated aim. And you've probably seen me talking about all kinds of topics relating to the energy and physics and engineering, all those kinds of things on the BBC, on the Cosmic Shambles Network, and on Fully Charged. So I am very excited about the discussion this evening. We have so much to say, so many questions to ask and answer about how engineering can power a green revolution in British life. Over the next 30 years, 2050 sounds like a long way away, but in some senses it is, and in some senses it isn't. So this is the first MacRobert Award discussion. It's supported by the Royal Academy of Engineering. But the award itself has been running since 1969. It's grown to be an extremely prestigious prize for UK engineering and innovation. Britain has a long history of engineering innovation, obviously, and over the past 50 years, the Royal Academy of Engineering, with support from the Worshipful Company of Engineers, which is a great name for an organisation, they've recognised some absolutely astonishing achievements via this award. And I'm lucky enough to be joined by a number of those involved with the award this evening. But before we meet our panel for this evening, let's have a look at the history of this award and take a quick look at some of the past winners.
Historically, people have always thought that they wanted to get across the River Severn because it was a natural junction to get from the West Country to South Wales. So the need was there.
Kinect was the first of its time in controller-free motion gaming. The groundbreaking work was the ability for the camera and the Xbox to track the motion of your body in real time.
Raspberry Pi is a little computer that people use to learn programming, to drive factories, to make robots, to automate their homes. You can do pretty much anything with it.
Over the last 50 years, the MacRobert Award has celebrated the absolute pinnacle of UK engineering. Engineering ingenuity, but also commercial success and societal benefit. When you look at what UK engineering can do, you see that nothing's impossible in meeting the grand challenges that we have to face. And I would expect to see some things that materially change our lives throughout this century.
And those were just some of the past winners. Just imagine how much richness there is in all the rest of them. So let's get on to introducing our panel for this evening. We have Professor Sir Richard FREng, who is the chair of the MacRobert Award Judges, Cavendish Professor of Physics at the University of Cambridge, and the director of the Winton Programme for the Physics of Sustainability. We also have Dervilla Mitchell CBE, who's a fellow of the Royal Academy, an executive chair of Arup, winner of the 2009 MacRobert Award for the water cube at the Beijing Olympics, and a member of Arup's global board. Next, we have Dr Enass Abo-Hamed, who is a Royal Academy of Engineering Enterprise Fellow, part of the This is Engineering campaign, a very enthusiastic member of it as well. And she is co-founder and CEO of H2GO Power, an engineering company which is developing new ways to store clean energy. And last but not least, we have the winner of this year's MacRobert Award, Tim Burnhope, and he is a Fellow of the Royal Academy and the Chief Innovation Officer at JCB. Tim and his team won the award this year for their innovative electric digger, an excavator, the world's first volume-produced fully electric digger, proving beyond all doubt, if anyone had any doubt, that it is perfectly possible to make powerful construction machinery without an internal combustion engine. So welcome to everyone. But just before we get started, let us wave the flag a little bit for the winner this year, JCB, and have a look at the work they did to earn this award.
Our sustainability is paramount. It really is. It's the reason that we're doing this. This product is leading the way in sustainability in that it's the world's first all-electric excavator. And the technology that's in it really is the foundation for application in many other machine types.
This new electrification technology, when we started, was completely new to us. Bob and I had to go back to university to the base understanding of what electrification was all about. The key drivers for this invention were defined by our customers. Zero emissions, full day shift on one single charge, really easy to use, really easy to maintain.
We've been developing UK technology that's been developed for the automotive industry, and we've augmented it further by taking it into an off-highway application.
This entry is different because it's a really passionate UK company with a world first, and they are combining all sorts of different types of innovation, and they have a really strong desire to make a positive difference in the world. But they're doing that with attention to the commercials, so they're thinking not only about their own business bottom line, but they're thinking about the business benefits to their customers. And so actually that's just completely what the MacRobert Award is about.
Well, let's get stuck into the topic for this evening. We have had some fabulous questions sent in beforehand, but if you're watching along, you can also send in questions along the way. We'll be trying to answer questions live, as well as the ones we got beforehand, as well as all the ones that I've got for our panel. If you'd like to send in questions live, you should be able to see a YouTube live chat. Stick your questions there, and we'll do our best to keep up with them all. And the people who did send in questions, you will get top marks for putting in some very thoughtful questions. And so although we won't have time to cover all of them unless we're very efficient, you will get top marks for critical thinking, which is a very important trait for an engineer to have. So let's start on, a zero carbon society it's a big thing to think about. It's complicated. There's energy and transport and buildings and aviation and heating and industry and food and all sorts of things. So we've got a load of stuff to dig into. But I want to start with the award winner and to use the award as a way into some of those topics. Now, I want to go first to Richard. You are the chair of the judging panel, and you clearly had a lot of fun judging this award. You got to see behind the scenes of all sorts of different projects. And I wanted to ask you, first of all, about the fun of being a judge, but also how this question of better engineering, how do we marry the two things together? Zero carbon, the things we need to get to a zero carbon society and better engineering all around. How does all of that work?
Well, thank you. Let me start by, it's the first sort of virtual face-to-face conversation I've had with Tim, and congratulations on winning. It was a very popular choice, the achievement that you've managed with the electric digger. It's a beautiful exemplification of what engineering is. You had assembled many different pieces from scratch. You built up a new team, an area where you previously, and the magic was that you engineered it, but you understood who the customer was, because you understand that very well. And the magic of engineering, I think, is to understand what the customer needs and will use. And engineering to achieve that is the point when you have a product that everyone likes and the take-up is high. And what you've achieved here is a demonstration, as I see it, that the components for electrification of transport are much more available and assemblable than I previously thought. It's a lovely example of what I think decarbonise.
So you were saying, this idea of it being a better product all around. So Richard, you talked to me earlier about the idea that if we want to achieve things for a net carbon, net zero society, it's not really it's not worse. We don't have to live in a worse world with worse products that just happen to be zero carbon. These are better.
Well, in this case, we have the JCB digger outperforms the diesel version. It's quieter. It doesn't produce exhaust fumes. It ends up being more usable. So it's just a plain, attractive commercial product. And for me, that is, if we can generalize that, then the transition to a zero carbon economy becomes much easier. If there's no pain, then the barrier has been taken away. Now, there's a huge set of problems about getting there fast enough, and I don't want to trivialize that. But these demonstrations that we can produce things which are just plain better is a great start.
Well, we'll get to the timescales later on. But Tim, I wanted you are so enthusiastic about this project, which I love. But the question, the thing I would love you to talk about a bit is, you know, you made the point to me that the sorts of things that win engineering awards are sort of spaceships and shiny things and all this kind of sci-fi technology. And yet you couldn't build any of that without a digger. And just talk to me a little bit about this, the sort of misconception we have that it has to be shiny space-going technology to count as good engineering.
Yeah, I mean, first of all, we are truly delighted and truly honoured to win the MacRobert Award. Something we as engineers all dream of. It is, for me, the world's most prestigious prize, and to sit alongside or stand alongside those projects that have won it in the past is for us as a business, quite humbling, but at the same time incredibly spectacular. Great endorsement for our team, our whole engineering team, and especially our electric team that really embraced this very quickly. I think reflecting on the challenge, I think we look up to automotive, to aerospace. We're always looking for those technology leads. But this was a bit of a conundrum for us, doing a digger, electric digger, to a tough customer base who know exactly what they want. So it's got to be better than the existing product. It's got to be a proper product. It's a work tool at the end of the day. It's not any form of fashion item. It has to be commercially feasible. It has to work all day, and it needs to be great for the operators. And the thing that we did, we took those key customer requirements away, defined them, and some of them were pretty tough to achieve. But I think when we took that machine back to the customer, and it could dig better than the diesel machine, it could be more powerful, it was zero noise, they could talk to everybody else on site. They just said, wow, this is an incredible machine. Then the test was, how long will it last for? Can it run all day? And we've done extensive tests to make sure it could, without question, last a full day shift. Then they fully embraced it. And I think for us, it's a game changer for us in terms of thinking internally and believing as a team that we can do it, and we can make that scalable, but also to our customer base to say that actually this technology can work in our industry.
And just talk to us a little bit, Tim, about because you had fun with this challenge. Talking to you about this, it's not like you set out and go, oh, we've got to do a thing. We're a bit, the world is telling us we're kind of, it's stick rather than carrot. You were well up for this, weren't you?
Yeah, I mean, we started to get some feedback from our customer base that, I guess if you're in London today, you're not allowed to extend your house upwards. So most of it is now basement work, basement extensions. We've got hotels now that are digging below ground, creating several floors. So all of a sudden there was a demand for a product that was literally kind of the indoor job site. So customers are coming back and saying, I'd like to do this, but I need expensive ventilation. How do I make this work? So we sort of decided it's time to have a go. And myself and Bob Wormsley, who's the head of our electrical team, if we're honest, we're engine, we're diesel, we're hydraulics people. That's where we are. And we decided, we talked to our chairman, who's a great leader, who tells us just to have a go, get on with it, have a real sense of urgency, become determined. So we just decided this would be the ideal product. We ended up going back to get some help from Warwick University. We went down, sat in a lecture theatre for a little while, and we went back through, told us what a battery is, what a battery management system is, and we worked our way through. That for us was great. It's we all know as engineers, it's all about constant learning. And we firmly believe that this decade, it is one huge challenge to get to 2050, but actually it's got to be the most exciting decade for engineers. Anybody coming into engineering at this time, there is no greater opportunity to express yourself as an engineer on the path to or the road to zero.
Well, let's use that to go to one of the young engineers who is very keen on this challenge, to Enass. Now, just briefly, Enass, the company that you've started, H2GO, just tell us a little bit about what that company does and connect it to this idea of a net zero.
So H2GO Power started from my PhD when I was a student, and thank you very much for referring to me as a young person. Not that young, because that journey has started 6 years ago, and have definitely grown up on the journey. So H2GO Power is about storing renewable energy in the form of hydrogen for long duration, a challenge that could really address our decarbonizing targets if we get the engineering right. As I have started to describe it, its journey, we don't have definite answers for all the questions that we have started the company to address. How do you store hydrogen? A huge amount of it. Volumes that you cannot compress, or you can exceed the compression with, for example, by opting for solutions like storing hydrogen in solid state forms, and importantly, looking at exceeding with performance the other technologies that you have available on the market, batteries, for example, or you really want to be playing in the playground where fossil fuels and emitting fuels are the major player to address energy needs. So this is really the area and the playground that we are targeting, and we're developing products for.
So let's just the one of the questions that often gets asked about renewable energy, and it was asked in a couple of forms by our audience actually, is it the question of intermittency, that the wind doesn't always blow, the sun doesn't always shine. Give us some context on how hydrogen can help with that specific problem, with the problem of energy storage.
So basically, since we want to move away from what we're calling reliable sources to supply power, diesel, coal, and so on, and we want to rely on renewable energy, they are not that reliable in their nature in terms of a continual supply of power because of their dependency on the weather. So if you are able to produce energy very close to the user, that's not going to happen for the entire time frame that the user would need power for. That means that at night, if you're depending on solar panels, at night, what do? Do you go back to diesel, or do you store the excess amount of energy that you did not use during the time when the sun was shining? And with the capability of storing energy for long duration safely in a manner that allows you to put it next to the user, you can have a round-the-clock power supply, which is zero emission, and at the same time get the energy security that you're thriving for.
So let's just talk a bit, because when people think about net zero, often the first thing they think of is energy. There's lots of other issues, but let's deal with the energy to start with. Now, I've got some a pair of questions that came from two people before the show. And these probably for Richard and Enass, but the others might like to chip in. So from Dr. Dame Sue Ion, she wanted to know what further steps can be taken to give nuclear energy a realistic chance of realising its potential to be a contributor to a zero carbon society. And then from David Kingham, the UK has a world lead in fusion research. How can we turn that lead into a deployable technology? So we've got all these we've got renewables, all these things, but then there are these two things hanging around, nuclear and fusion, the power of the atom. Where do these fit in? Richard, you can go first on this.
Well, nuclear has always provided, well, in most of my lifetime, a very important component of our electricity supply, and it still provides a surprisingly large fraction of base load, and we're going to miss it when it goes. The challenge, as we've seen, has been that it's been expensive and slow, and somehow caught up with the politics of it as well, and which is very disappointing because there's no logical engineering reason why we couldn't push things along faster. There are some very interesting developments. There's a lot of interest in small nuclear reactors, where the proposition, a very sensible proposition, is that if they can be made more or less on a production line, a lot of the cost associated with testing integrity of welds and whatever can be done before installation. But I think it's going to require a big effort to make that commitment. And we haven't quite got there yet, which is frustrating.
And how does the cost work out? Because nuclear, the one thing people know about nuclear power is it's expensive. And the one thing we're learning about wind energy is that it's very cheap. How do those two things balance out?
Well, the observation that I think is engineers understand, and it's taken me a while to get there, is that when things become mass produced, we get very good at making them better, more cheaply, smaller amounts of materials, less embedded energy. It's a win-win. And that's certainly been true for solar, and it's been true for wind. So by that logic, with nuclear, we want to get the scale up. We want to arrange that construction is routine rather than everyone being a special job. That from I'm a bystander on this, but that would be my main push.
And you were very quiet there on the question of fusion. What do you think about the idea of us having realistic fusion power before 2050?
Well, first, we should celebrate the fact that the UK effort at Callum on the plasma physics and engineering is absolutely world-leading. The business of getting tokamaks to be able to contain the plasma for long enough and to get it hot enough is a huge achievement. I mean, it's a real scientific engineering high spot. I look at the timescales set for the operation of ITER, the big international next generation fusion demonstrator in France, and it's quite slow. I mean, it won't be till well into the 2030s before it will be up and running. And that, if you like, is the best understood timetable for fusion, and it is really quite slow. And there are some engineering problems that have to be sorted out, such as how to convert very energetic neutrons into useful heat non-destructively.
So Enass, let's take a shift back to Enass and because your view on this, you're dealing with these new renewables. You're perhaps from a generation that hasn't, not as aware of the big beasts of the nuclear or fusion kind of mix. How do you view these different energy sources? From your point of view, do you think they're necessary, or do you think we can just move on to a future powered by solar and wind and with hydrogen storage, and we just don't need any of it?
I think if we are motivated by achieving targets by short time frames like 2030 targets, 2040 targets, 2030 targets, we must admit that this is the type of engineering work that would take a little longer to improve, run at scale, invest in, get the costing prices right. So this is a very important type of technology and research to develop, and we should not ignore, of course, and enough resources should go into growing these. They are equally important. However, we must admit that the time scale that we need to meet our decarbonization targets, because we are actually sitting right to a clock that is ticking, and we cannot ignore that. So we must work with what could achieve that faster, and wind, solar, and hydrogen are definitely very good candidates to meet these targets on time, or the time frame that we're talking about.
Speedy technology. Let's move on from the energy topic to something that I think is really important, but a lot of people, it doesn't get discussed enough. So let's discuss it. So Dervilla, this is one for you. And the idea of retrofitting buildings. Tell us a little bit about why the built environment is so important and why retrofitting is perhaps an even bigger question than how we build new buildings.
So retrofitting is indeed a big challenge that sits out there, because about 35% of the global emissions are due to the built environment. And in fact, if you look at cities, that figure in a particular city is probably much larger than that. So that's one issue, we have to address that. But also, as we continue to build, we continue to increase those emissions. So there must come a point in time where we stop and take stock And with the net zero target and that ambition, we now must at this time think about how we change. At first, we might not be able to stop building because people do need new facilities and they need new and different sorts of buildings. You know, we just have seen this year, we're going to need new hospitals and we're going to need different sorts of schools. So it's very difficult to say stop, but you can work really well at retrofitting buildings. And the best of those are those where you really look at the very many means of transforming a building from its current use into a new use, minimizing the amount of materials you use, producing a building that's going to be really efficient in the future. And that sort of change is going to make a huge difference.
And these projects can be very tricky because obviously a building was usually very well designed to be the way it is, and you can't just you can't just stuff extra insulation in or stuff extra. You know, it doesn't kind of work like that. And I think you had an example of Triton Square in London. Tell us a little bit about that project and what you actually have to do to retrofit a building.
I love the example of Triton Square because I think they looked at so many different ways of both reducing the embodied carbon in changing the building, but also they looked at the operation. So let me give you an idea of the range of things they did. They strengthened the foundations rather than putting in new foundations. They strengthened the structure by wrapping the concrete rather than putting in new structure. The bit I really love is that they actually took off the facade, brought it to a pop-up factory in Basildon, took out all the gaskets, refitted the gaskets, and put the same facade back on the building. So, and then the air handling units, the old air handling units were taken out of the building and they were put on ships and sent to South Africa where they are being used in a building there. So these AHUs, which might have been normally thrown away, were given a new lease of life. So I've only probably covered a few of the elements. The facade and the envelope is the one that intrigues me the most because the normal practice would be to take things down, put and throw them away. So we must focus on a whole range of things. I could go on, but I know you want me not to keep speaking, so I'll stop.
Well, some of these issues might come up, they might come back later on. But I think I'm also interested in the idea of retrofitting because you've got to literally reverse engineer quite a lot of things, and it's a big problem. And it's much easier to think about building new things, but we need to reuse things and recycle them. So I want to move on to Enass. You said something about it's about engineering, and there's this idea that we understand for what is called pure science that there is science that we do because it's interesting and it's curiosity driven and we don't really know why we're doing it, but let's do it anyway. And there is science that we do because it's applied science, because we need to know a thing in order to do something. But in engineering, we have applied engineering. That almost the definition of engineering is that it's applied, but you think that should change. Tell us about that.
Just to clarify that these we can define science and engineering and separate them, but maybe as well, whilst we're talking about change, because we do need change because of climate change, because of the world change, because of everything changing around us. Maybe as well the definition should change, and maybe we should see like these disciplines merge, and theory will have an application. An application would need theory to on route to implementation and engineering and testing and deploying. So we might want to think about the future of science and engineering as one discipline or a multidiscipline that represents one area. I mean, the definition, the traditional definition that we know, maybe have not prompted enough people to join disciplines because they thought that they belonged to one category and they wanted to do something else. But maybe now we should be driven. But what are the type of jobs and work that we need to be in the future doing, and work back from there?
So I think you've got an idea about, it's not exactly blue skies engineering, but a more open-ended form of engineering where we understand that if we learn how to do things, it will be useful. Is that your view?
Yeah.
So, because I think that's a great, I mean, it's a lovely, if you look at the history of science and engineering, as you say, there's not a clear line. There's lots of examples of people trying stuff just because it was interesting, and then it turned out to be useful. And I think engineers, within the constraints of time and money, I think it's worth. I'd love to see basically build a giant shed, put all the engineers in it for 2 weeks a year, and just see what they come up with. I think we should do that.
Yeah. Just to add to that, Tim probably could tell you that they needed a team of people with different expertise to build one great award-winning piece of engineering. So it wasn't like one discipline, one expertise, one focus. It was multiple disciplines that yield to one great result.
And Tim, do you see, because you took having an aim for this, but you're also prepared to play? Like, do you see the engineers in your team as being prepared to play even if they're not sure why they're doing it? That being able to explore as an engineer, do we do enough of that?
I don't think we do, if I'm honest. I think that's our challenge, and I think it really is. We're lucky as a business. A few years ago we invested heavily in an innovation centre where we house people and we have a go at things. We set up crazy projects and we have a go, and that is fantastic. It doesn't always get the answer, but it definitely pushes the boundaries. So I think it's an absolute yes. I think the big challenge for all of us is sometimes as engineers we can overthink it. We can spend too much time trying to conclude, for example, is it diesel or is it electric or is it hydrogen, when actually it's going to be a combination of all on the road to zero at different times, different intervals, when the technology matures, when we have different breakthroughs. And I think that's the bit that we've got to be more open-minded than ever and try and work out. And what we're really finding is we go through the different technologies before we adopt something like hydrogen or battery. The first thing we've got to do is to minimise the energy consumption of the existing products. So the greatest innovation can be, for example, over the last 10 years, we've improved our fuel efficiency by over 50%, and that helped us to then electrify products. Otherwise, we would have needed twice as many batteries at that point. So we want to continue the journey to make product super energy efficient. And I think that's a big part of the learning, and that's going through every ounce of the product, understanding why we did that. Why do we choose that hydraulic joint? Why do we do it through that direction, the size, the flow, the pressures? The great thing is it takes every engineer back to first principles. And that's where you discover and learn and have breakthroughs. And we're already starting to see some projects that we've put out to look at our Generation 2 mini excavator, which we're already in awe of, that we just couldn't believe we didn't come up with 18 months ago. So for me, it's constant learning, pushing the boundaries, absolutely.
Let's get on to the question of how engineers how do you choose what to work on? Having said it's a good thing if we have fingers in a few different pies. And I wanted to come to Dervilla on the question of procurement, which is, there's all these, you can have wonderful engineering things, but then someone in a company sits down and says, how do we balance all these different things? And you think that procurement shouldn't just be about cost. Tell us about that.
I really do think that, procurement has been over recent years driven far too much to cost as the deciding factor. And I think we need to really move away from that if we're going to achieve different outcomes. And so you've got to put into the procurement assessment something about quality, something about social outcomes, something about reaching net zero. So if you can build up a different set of outcomes rather than cost, I think we begin to go about achieving the outcomes we desire rather than just the lowest price.
I think that's a really important point, and it comes on to a question that we had from the audience beforehand, from Dr. Kamyol Mehran, in the context of, we're just maybe coming out of lockdown a bit here. COVID has obviously changed the world, and it's a question for all of you in different ways. How will COVID-19 affect the investments on research and development for decarbonisation projects? So it's a question where if you only consider cost, maybe you go one way, and if you only if you include other considerations, you get things differently. So how's COVID affecting all of this? Richard, what do you think about this?
Well, we don't know, but to be an optimist, I think the getting used to cities with clean air has taken many of us by surprise, and it's a demonstration that we could actually have clean air if we wanted to. It's given us a taste of what life could be like if we made a serious push to get rid of internal combustion engines for transport in cities. And I think there's some sense that is where the investment is going to go, has had a real push.
It is really positive. It's really positive, isn't it? It was a good thing. It's not so good now that the traffic's come back and the air pollution's come back, but everyone remembers. How about the others? Enass, how do you see COVID affecting R&D funding for zero carbon projects?
So I think it's just like it opened the eyes of like many investors who have a very strict criteria for investment, which is returns, fast returns, that maybe actually this was not the perfect metric, and they should look at. I'm just repeating Dervilla's words in other words. Maybe really to get into a different outcome, which we all think at the moment the climate is getting back at us, and we got to change. And maybe that change is investing in different directions under different categories and criteria.
Anyone else on the COVID effects? Because it's quite an interesting question. Suddenly it turns out the world can change very quickly if it has to.
Well, can I just say, I think that COVID really has given everyone a moment in which they have to think and reflect. And I know there's this phrase used, build back better, but I think we should think about, how we build back smarter. And that means using technology. Look how we're able to hold this event this evening, utilizing technology. And we've all accepted that we've been able to change and change for the good. So that has been great. But also for us being more thoughtful about the user, because I think it came out early on in this, the customers are the users. And we saw when schools are trying to come back into use, the corridors aren't wide enough. They haven't thought about how to expand the classroom. So I think we need to really think much more smartly and about the users going forward to build flexible and adaptable buildings. So I think we will think differently going forward about how we design, and I think that'll be a great thing.
And one of the things that I hope will come out of all of this is an appreciation. We can see in society that we're suddenly appreciating the things we never thought about. We never thought about food supply systems. We never thought about, where things were coming from and how much, just-in-time supply systems. And I think that one of the things so I hope this is an era of renewed appreciation for the things we don't normally think about. And so I've got a couple of questions for Tim, and one of them was sent in beforehand. These are two related questions for you, Tim. And this one was from Alexandra Smith, and it's, do you see the electric digger as the start of a transformation of the quarrying and mining industry, which is known to be very energy intensive, but no one really thought about that? And we've also had a question on the YouTube channel on the chat, which is that do JCB think they'll be able to scale up this electric technology to bigger diggers and other machinery? So all those energy costs that we don't think about, most of us normally, do you see that this might be the start of a big change here?
I think if I can just touch back on the COVID-19 pandemic, I think for all of us it was interesting to watch how the world reacted. And I think the world got a lot of things right and maybe got one or two things wrong. But for me, it's all been about constant learning. It was just a great challenge for humanity. And I think there are so many parallels with the road to zero that we've got to reflect on that. So we saw some incredible urgency where people just accepted there was a crisis. where we accepted we needed to fix that crisis, and where we all joined together to overcome it. And I think when it comes to the investment in the future, I know we've all been thinking differently since we've been back in the office, but it's almost given us a determination that if we can do so much in such a short space of time, then we've really got to embrace that, because the COVID-19 will go down in history as being one of the greatest challenges that we've all come across, but it's nowhere near as big as the challenge that we've got on the road to zero. And I think if we can embrace it in the same way as a world challenge, pulling the technology together, sharing the technology, sharing the ideas, then I think we can make some real progress. But we've also got to question, why would you continue to invest heavily in projects that aren't related to the road to zero going forward? I think that's the question for all of us. Coming back to the electric side, the electric dig has been fantastic for us, and we see that machine as a technology platform. So when we designed it with an architecture that would allow us to take that architecture, take the engine out, put batteries in, and the other systems. But actually, we now know that that's transferable. So where we used to transfer powertrains between machines, now we're going to put an electrical system in that's very transferable. So we believe now we can move very quickly, very rapidly to employ that architecture across a host of different product ranges. We have, as a business, 16 different product groups, 350 individual products. We can't design them all as new individual products. So we're going to put that architecture right across, but we're in a great position. Does it scale up to mining? If you'd asked me a year ago, I would have said no. I think there's a possibility of yes, but we've got a lot of learning to. But what it's caused us to do. So I guess we never thought we could crack the electric Mini and make such a fantastic product. Now we've cracked that. We've got the confidence. So we've worked on kind of the low energy product. Now we're going to move to the medium energy product. And what we've realised, if we start working on the high energy demand product, then we'll be able to crack anything. So we're going to, and you've probably seen more recently, we've just shown the world's first prototype for a hydrogen fuel cell 20-ton excavator. So again, great experiment for us. We knew nothing about fuel cells, so we got together, we put that technology in. We're learning a lot. We're learning a lot about how you package hydrogen, how you use hydrogen. But for us, it's a great experiment. If you can start to work on the even bigger equipment beyond that, then I think we can do whatever we want. There's going to be big challenges on the way, huge challenges, but it's how we embrace it. But really, it's about starting the journey, just getting amongst it, starting the journey, and then when we hit the problems, we'll figure them out as we go, and we'll make some real progress.
And I often say, I mean, as I'm a scientist more than an engineer, but I often say the fun of it is not knowing what I'm going to do when I wake up in the morning. You don't know what you're going to learn today. You don't know where it's going. Now, I would like to move on to an issue which is about who does all of this. Because there's this kind of myth, well, you can tell me whether it's a myth or not, that green technology, that all these new shiny ideas are created by startups. And yet we have a winner of an award here, JCB, who are definitely not a startup. They've been around for a while. And Richard, I just wanted your perspective as the chair, one of the judges who's looked at lots of projects. Where do you see this balance between startups having new shiny ideas being, fresh off the blocks, and the established players? How do we use that? How do we get that right?
Well, there's no simple answer, but I would say that the team that we saw with JCB is a sort of startup within an existing company. I mean, it was a new team pulled together, and I think it had the same freedoms to explore, but it had the advantage of a deep understanding of what the customer really wanted, so that the right thing was engineered. And one of the problems with absolute startups, and I can say this from experience of my own, is that we start off presuming what the customer wants, and we discover later that we weren't exactly right. And if we're lucky, we manage to redirect. But I think it all comes down to teams. There's probably a magic size. It can't be a huge team that can start something really new. But wherever that team is, it has to be in the right environment to be able to sort of learn quickly, usually about who the customer is.
I love the idea of startups with That's a great way of having your cake and eating it, isn't it? Enass, you have started a startup, but I wanted to use that to get onto a more specific topic, which is, without making judgments about the others on the panel, the question of generation and different attitudes that people of different generations might have to some of these problems. So what's your view on this? And then maybe we'll get some other views on it. Does generation make a difference? How did it affect you as you were building all of this up?
I think maybe it has to do with the appetite for risk and the comfort of doing something that you don't know exactly what it is, and you're learning, right? You're figuring out like who the customer is, and sometimes it could take you a year or two, and you're comfortable doing that because you haven't experienced anything more important than that in your life previously to do. So you can give it a go. But I think if you start from a point in your career where you grew up in a system, everything around you is structured, and you had great experiences and a learning that was like really given to you, I think you'd find it very uncomfortable to step into an unknown territory and feel comfortable with figuring it out and taking the time to do that. So maybe this is only where like age could or past experiences could really like have an impact on the age of entrepreneurs and the age of startups that we all think that mostly they are started by young people who don't have a lot of experience.
So just before come back on this, there is something which we do think we see in the younger generations, which is a much more direct connection to Earth as our life support system. Do you think there's more urgency for young people on some of these problems?
Yeah, I mean, I think we all know who Greta Thunberg is, and she's in many countries you can call her underage, right? But I think the fact that she's celebrated so much because her generation is closer to the beat. It's closer to, if climate change is not being solved on time, that is the generation that is going to suffer the most. So that's why they need a different training. They need a different perspective, and they do have that already.
Right, the generation thing. Who's going to take that on from the other three of you? Go on, Richard. I saw you.
Well, in defence of the elder, the whole sort of startup culture in the UK has matured very effectively in the last 3 decades that I've been involved with it. The venture capital community 30 years ago wasn't very large, and it was relatively naive. And I think you need a full basket of skills. In the same way you need to get the right basket of skills to get the technology right, you need the right skills to understand how to place a really exciting team with a great idea for some new technology in the startup in a sort of sensible business environment. And the availability of people who know what has got to be done, who generally are a little bit older, not always, has got much greater. I mean, I'm obviously aware of what's gone on in Cambridge, and it's a pretty sophisticated environment now, and I think that has made the success rate of startups go up considerably, because you can plug in, you put your hand up, I'm going to start a company, I've got a bit of seed funding, and you can get a lot of advice for free from people who really know quite a lot about it. So that requires all generations.
We're not throwing out the experience. Tim, you are very interested in the passion that young people have, and also it's a way of giving them agency, that they can do something. What do you think about the generation question in engineering?
Well, I think it's fantastic. We set up a JCB Academy to develop young people to come through into the industry with a number of other partners, and we've really fed our young talent into our organisation. And the thing we love about that is that real mixture of expertise. So we do want people that understand how to make a great digger, but at the same time we want people with passion, people without fear, that just want to really have a go. Young people are used to charging their phone every day, used to using all types of new technology. And I think telematics, all of those areas that we've kind of put onto the product, and the same with the electric, we know how to adopt the technology, but there's something about the young people where they can bring more out of it. They can really use telematics to do great reporting because they're brilliant with apps. They can, it's great for this new world just to adopt, change things quickly. So I think it's a real good balance. As Richard said, we really wanted to create almost a startup within the organisation to do this, and it acted like a startup. I think one of the things we had to present to the committee. So when we first looked at our product, we wanted to work a full day, but in terms of range, the first machine only lasted 25% of that target. And of course, the traditional members of the team said, "Well, we just need to put lots more batteries on." And it was, but you can't, because it's a commercial proposition. We can't do that. We can't just keep adding batteries. So we suggested we kept the batteries the same, and we work on the energy. So we look at the electric motor type. We look at all, and actually we got it to 50%. Then we got it to 75%. But through 4 or 5 iterations of going back and getting into the detail, but having that passion. And I think that's where you've got that openness and that whole drive between every generation, but this real desire that comes from the team. And we're really, really lucky. I've got Tom with me, one of my exec support team. Tom again drives me, he challenges me every day. He's not scared to ask questions about why we're doing this, Tim, why aren't we doing that? And that's what makes us healthy and fresh. And so it's so important to embrace every member of all generations.
Okay, so I want to move on to something that all of you hinted at there, which is the question of timescales. And if you ask a climate scientist or someone like me who works in Earth system science, and you say, "What do you think about 2050?" They say it's too late. We can't wait till 2050 to have a net zero society. So are things? The question is, are things moving fast enough, and what do we need to do to speed them up? Dervilla, what are your opinions on this?
Well, I think that we are not moving fast enough and we need to move at pace. But how do we do that? Because as we've heard this evening, this is kind of quite a wicked problem with many, many dimensions to it. We've talked about energy, we've talked about transport, we haven't mentioned land use, we have talked about housing. But what this is going to entail is a transformational change in almost every single arena. So we have this big challenge to address, which could make us go slow. So I think the key to this is adopting what changes we can now, but also not forgetting the longer term and continuing to innovate for the future. So I think those things in combination. And I think that us taking a systems approach to this problem will enable us to understand all the parts and how all the various systems can be integrated together and deliver very efficient solutions.
What do you think about timescales? Enass, how about you?
So just to add from Dervilla's intervention, it's just I think there is change happening. Engineering-wise, there is quite a lot of great inventions coming up. We are seeing solutions being implemented at scale. Are they fast enough? I think we can always aim for better, and aiming for better might mean that we don't set a 2050 target. We start looking at 2025 targets and 2030 targets, and maybe like a 5 years targets review and assess, and then set another target based on the assessment rather than saying 2050, because many governments that will set the rules for 2050 will not exist in 2050. So who would we hold accountable if we did not meet our targets in 2050? So maybe bring the targets closer and then keep assessing and moving the target based on how well we are doing.
Deadlines always, some people that work to a deadline, don't they? Well, so there's a question we had from Rachel Skinner beforehand, which is how do we add urgency to these discussions? There's lots of people talking about things like we are now, but what do we actually do in practice to make this an urgent problem that people really take seriously? Richard, what do you think about
that? Well, I think it requires the whole of society, including government, to understand that everything has to change, and that the current sort of infrastructure of incentives, of regulation, of safety, have been honed to support the current system, and quite often can provide unintended barriers for the sorts of changes that we should make. But we have some nice examples where we have taken a chance. So the feed-in tariffs, say, for offshore wind, much derided globally, have turned out to work. And we've now got, the UK is the centre of the industry with installation and support of offshore wind, and the prices come down wonderfully well. So that's an example of how it can work. But we have problems. I mean, too often, we're not going to buy, well, I'm probably not going to buy an electric car this year because I'm going to wait another couple of years. So as a society, we need to work out how to set the right incentives so that nationally we're on the front foot, that we take the lead, and the prize is that if we get that first, we have the skills, these create jobs, good jobs, these are exportable skills, we will win, but we have to take a bit of a risk to get.
And Tim, as someone who's in a company working on these things, what do you need are you taking this as urgently as you can? Are there things that would help you make these changes more quickly? What's your view on the timescales?
I think the timescales are challenging. I mean, we plot that road out. So if you do it over 30 years, 6 times 5 years, you can work out the percentage every 5 years that you've got to achieve for a straight line. I think the greatest opportunity is to reduce CO2 in the short term. So for me, we need to try and bring the temperature down faster. That is for me, and we've got to embrace all technology. So for example, today, I know we're talking about new technologies, but the most cleanest fuel efficient diesel engines, for example, will help us bring down CO2 in the very short term, and we shouldn't be scared of admitting that. We need to work out with the maths exactly what we need to do, what we can invest in now to bring CO2 down. But the urgency starts now. That is the crucial part. We're still going to go potentially through population growth, so the challenge becomes more difficult, where more population will want more energy. So what we can put into now is for me really crucial. The other thing is that
very briefly, if you would,
we've got to somehow give the consumer confidence. We need more pull from the consumer. So therefore, it suggests we haven't quite got the products right. So we shouldn't be waiting for the technology. The technology's got to be right, and we've got to make it good enough for the consumer to say, "I want it now," and then the change will come very rapidly.
So there are some big serious questions here. Just before I've got a question for you all before we finish, but before we get there, we have one question, which is a very good question from the audience. Michael has a question for Richard. Richard, you were the chair of a panel of judges who awarded the most prestigious and UK's most prestigious engineering award to an electric digger. Did they let you drive the digger?
Well, unfortunately, it was all done virtually this time, and we were all really disappointed. I'm sort of hoping, Tim, that maybe when the lockdown is finished, we might.
the chair. Yeah. Like to drive your digger.
You are welcome at any time. Anybody that wants to come and try it, you are more than welcome to come at any time.
You are very convincing, actually. Yes.
I'd like to try the hydrogen digger.
Oh, right. You're going to have a party now. Brilliant. I love this. So, okay, now just to finish. Now, I think one of the things about this net zero challenge is it's a societal thing, but it's a civilization thing. There's the immediate survival now, what we do in the next 50 years to our planet, but on the very long time scale, this is a question of our character as a civilization. It's a state, we have to put a line, some kind of line in the sand and say this is who we are as the human race. So I have a question for you. Richard said in a conversation with me last week that civilizations will be remembered by their objects, which is very much the case. So my question to each of you, if you've got an idea, is which engineering object or engineered object, what would you like our society to be remembered by? And Richard, because it was your question, you can go first.
Well, the wonderful history of the world in 100 objects from Neil McGregor, director of the British Museum, which I think it captivated everybody. And that's what inspired me. For me, the most remarkable object is a microprocessor. So I'd probably pick an ARM architecture, being very pro-UK, processor in my smartphone. It is the most astonishing object.
And we do take them for granted. We didn't even get on to the topic of the end. It's so well hidden that we never get to see it. Okay, things we'd like to be remembered by. Enass, have you got something?
An electrolyzer.
Spoken as a true pioneer. Dervilla, what do you think?
Something much more mundane. It's sitting in front of me. You know, the iPad. Because it is accessible. We talked about users. It's accessible to anyone who's a child or very elderly. It keeps us well connected. We can use it to learn. We can use it to entertain ourselves. And it's totally intuitive. I think there's something about all those characteristics that's quite important.
In 1,000 years' time, when someone uses the latest version of your digger, whatever one of those has turned into, to dig up some archaeology, what would you like them to dig up?
Of course, it has to be the 2020 award winner, the electric mini excavator. The mini excavator that changed the world, the transformation into the electronic agenda and era, and that's what we would stand for. A futuristic product. This is the journey, the start of the road to zero for us.
Well, you heard it here first. They got the award from it. Today is just the first day of the rest of that digger's life. So we are out of time, very sadly. So it's been such a fascinating discussion. So many things we couldn't cover. I'm sorry if we didn't get to your question. Thank you so much to all our panelists and to the audience from the Royal Academy of Engineering for joining us this evening. Thank you to our fabulous panelists, Richard, Dervilla, Enass and Tim. Congratulations once again for the digger of the future from Tim. Congratulations to Tim and the team at JCB. I'm sorry that's all we've got time for, but engineering has plenty more to offer, and I'm sure the Royal Academy of Engineering will be keeping you up to date on all of it. So thank you from all of us, and good night.